In this video, we're going to be talking about fractions that are raised to a power. So the rule says that if I have a fraction raised to a power, then the numerator gets raised to that power and the denominator gets raised to that power. Again, we're going to break it down as to why. If I had the quantity x divided by y to the fourth power, that means I am just taking x divided by y times itself 4 times. And the way we multiply fractions is straight across the numerator, straight across the denominator. So x times x times x times x is just x to the fourth. And y times y times y times y is y to the fourth. So we can see that everything inside there got the fourth power. That will be true for coefficients as well. Everything inside would get that fourth power, or whatever power you are taking. So this first example, I have 3a cubed divided by b squared, that quantity to the fourth power. Everything in there has to get that fourth power. So 3 times 3 times 3 times 3, 3 to the fourth power is 81. So I have to remember to take that coefficient to the fourth power. Then we have a power to a power, right? 1 base, 2 powers. A cubed to the fourth power, we multiply 3 times 4 and get a to the 12th. In the denominator, I have b squared to the fourth power. Again, we're multiplying 2 times 4 is 8, so I have b to the 8th power in the denominator. And that's as far as you can simplify. In the next one, it's a little different because I'm not taking a power of the whole thing. I'm taking a power of just the numerator and just the denominator. So don't mix up these two rules here. If I have h squared to the fourth power, that's a power to a power. 2 times 4 is 8. So I have h to the 8th in the numerator. Then I have in the denominator 7h cubed. So I have to multiply 7 times 7 times 7 and get 343. And h times h times h would be h cubed. Now I'm not done here. Don't stop. I have too many h's. So I'm going to use the quotient rule. H to the 8th divided by h cubed. We subtract 8 minus 3, and that's 5. So I have h to the 5th in the numerator, because that's where I had more h's, divided by 343. And this last example here, I'm squaring that whole quantity. So meaning I have to square that 4. 4 times 4 is 16. I have to square that u cubed. So we multiply 3 times 2 and get u to the 6th power. V to the 0. It's 1. Get rid of it. 1 times 1 is still going to be 1. And 1 times anything is going to be itself. So that adds nothing. And then I need to also make sure I square that u squared. So 2 times 2 is 4. I have u to the 4th. Again, I'm not done. I have too many u's. U to the 6th divided by u to the 4th, we subtract. 6 minus 4 is 2. So 16u squared. Go ahead and try the 2 examples on the right. Examples on the right. I have a divided by b squared, that whole quantity to the 7th power. So I have a to the 1st to the 7th. 1 times 7 is 7. So a to the 7th over b squared to the 7th. So numerator and denominator have to get that exponent. So 2 times 7 is 14. I have b to the 14th. That's a 4. And that's as far as we can go with that. Down in the next example, part B, I have negative 6y to the 7th all being squared. So I have to make sure I square everything, including my coefficient and that negative. So negative 6 times negative 6 would be positive 36. And then 7 times 2 would be 14. So y to the 14th over, I have to cube everything in there. Y cubed would be just y cubed. And z cubed is z cubed. And I take one last step. I have too many y's. Y to the 14th divided by y cubed is y to the 11th. So 36 y to the 11th divided by z cubed. So again, I squared everything inside the parentheses, cubed everything in that parenthesis, and then I saw here the y to the 14th divided by y cubed. Now, you may question why I can do that, since in previous videos I've talked about how you couldn't do it in a case like this. You can't do that. The difference between the two types of problems is this one has a plus and minus. It's a sum and difference, and this one is only multiplication. Right? So multiplying, I could factor that totally out, and 3 of those y's would in fact divide out. Last example here, I have this large fraction and it's being squared. So everything in there needs to be squared. 3 times 3 is 9. X times x, x squared. X to the, y to the 6 times itself, or y to the 6 being squared, we multiply 6 times 2 and get y to the 12th power. In the denominator, don't forget to square that negative. It is inside the parenthesis, it is traveling. A negative times a negative would end up positive. And then x cubed being squared, we multiply 3 times 2 and get x to the 6th. Z to the 0 power is just 1. Don't stop. I've got one last thing to do. I have these x's that need divided out. So the 9 will stay the same. And then x squared divided by x to the 6th, we subtract big number minus the small. 6 minus 2 is 4. And I had more x's in the denominator. So x to the 4th ends up in the denominator. And I still have my y to the 12th. That would be as far as you can go. How'd you do?